These are the notes for section 3.3, proving lines parallel. The objectives are, number one, I will be able to recognize angle conditions that occur with parallel lines. And number two, I will be able to prove that two lines are parallel based on given angle relationships. So the first thing we start off with is a postulate. It says if two lines in a plane are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. You might think that you've already learned this, but this is actually the converse of something that you learned. So they're telling you that the corresponding angles are congruent, then the lines are parallel. Before we learned if the lines are parallel, the corresponding angles are congruent. So remember, to find corresponding angles, we should be looking at these two sets of angles here that I put in a circle, and they're in the same position. Their positions correspond with each other. So that would mean angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. In order to show that the lines are parallel, we only need to show one of those relationships is true. We don't need to show all four. So if you understood the last sections, this section is going to make a whole lot of sense because, again, we have another converse from something that we had. It says if two lines in a plane are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So again, now we're told that the alternate interior angles are congruent, then the lines are parallel. Once again, we had the converse of this last time. So remember, when we're looking at interior and exterior angles, we should write E, I, E. The interior is between the two parallel lines, and whenever we have alternate, that means opposite sides of the transversal line N. Remember, the transversal goes through both lines. So we would say angle 3 is congruent to angle 6. These are alternate interior angles. We also have angle 4 is congruent to angle 5. Again, we just need to show that one of these are true, and then we know that the lines are parallel. Very similar thing again here. It says if two lines in a plane are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. Once more, we have the interior between our two lines, exterior on the outside. Our transversal is line P. Let me trace that a little bit better. So we have to show that these are supplementary. Remember, supplementary means they equal 180. So that means the measure of angle 4 plus the measure of angle 5 has to equal 180, or the measure of angle 3 plus the measure of angle 6 equals 180. So both of these will be true if they're parallel, but again, we just need to show that one of them are true and the lines are parallel. So we have two more theorems that are just like this, and you should be getting the idea. If two lines in a plane are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Once more, we have exterior, so exterior, interior, exterior. The transversal is line N. So I'm looking for alternate exterior, that's opposite sides of the transversal, so I'm going to have angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Once more, if I say that one of those is correct, that's enough to show that the two lines are parallel. The last theorem we have, if two lines in a plane are cut by a transversal so that same side exterior angles are supplementary, then the lines are parallel. So again, we have that word supplementary. You need to remember the S means 180 for supplementary. So we have same side exterior. We label it E, I, E. My transversal is line P. And on the same side, I have the measure of angle 1 plus the measure of angle 8 equals 180 degrees. And we also have the measure of angle 2 plus the measure of angle 7 equals 180. So let's move on to the back page of your notes. We have a theorem here. It says if in a plane, if two lines are perpendicular to the same line, so remember we just got out of our logic and reasoning unit, this is our hypothesis because we have that word if, then the lines are parallel. This is our conclusion. So let's draw what P is. So I'll do P in blue. We have two lines that are perpendicular to the same line. So let's say I have lines A and B, and they're both perpendicular to line C. Well, what does that tell me? Then, remember that was the symbol for then, we say that A is going to be parallel to B. Line A is parallel to line B. So if I was going to draw this one more time, so this is my conclusion that I'm doing in black, I would put these triangles on the line. Remember, that's how we symbolize parallel. And these two lines right here, you should remember that this means parallel to. That means line A is parallel to line B. So we're going to go over a few examples to close. We're going to go over examples 2 and 3. I want you to try 1 and 4 on your own. So let's take a look at number 2. We should remember that this whole angle here that I marked is 58 plus 74, which is 132. This is one of the first things we learned in the year. Whenever we have two angles that are next to each other, we can add them and find out how big the entire angle is. So once I have that, I have these two sets of angles. Before I move on, I didn't really read the directions very well, did I? It says, is it possible, so is it possible to prove lines P and Q are parallel? So are lines P and Q parallel? If so, state the postulate or theorem used. So, are these parallel lines? The answer is yes for number 2, because the corresponding angles are. So yes, because the corresponding angles, remember they're in the same position, they're both in the top right. The corresponding angles are congruent. Remember, that symbol means congruent. Let's try number 3 also. So number 3, we have these two angles here. We have 75 and 115. They don't have any of the relationships that we've talked about. There's a number of different ways you can do this, but I do know that these two angles here form a linear pair. So that means 75 plus x, I'm going to call this x, has to equal 180. Remember, linear pairs are supplementary. So that means when I subtract 75, I get x is equal to 105. So now, I have both of these in the top right. They're corresponding angles. One's 105, one's 115. So are they parallel? No, because the corresponding angles are not congruent. So this symbol here means not congruent. Just like when we put a line through the equal sign, that means not equal. We can do that with congruent also. So let's keep going. Let's try these other examples. So let's read the directions first. Find the value of x so that line L is parallel to line M. So we're finding the value of x. We're going to do 5 and 8. I want you to try 6 and 7 on your own. But let's take a look at 5. We have these two angles. These are alternate exterior. So remember, we have the exterior, interior, exterior. We know that alternate exterior angles are congruent. That means they're going to be equal to each other. So we have 5x minus 5 equals 6x minus 20. I just set the two equal to each other because in parallel lines, alternate exterior angles are equal and congruent. Whenever I get my x's on one side, I subtract 5x. I get negative 5 is equal to x minus 20. I add 20. I get x is 15. So is that where I want to stop? Yes, find the value of x. So that's what I did. The last one we're going to do together is number 8. So again, we have the exterior, the interior, and the exterior. These are both on the interior and they're on opposite sides. So these are alternate. Interior. And we know these are congruent on parallel lines. Remember, this is 90. So whenever I set the two equal to each other, I'm just going to have 3x plus 15 is equal to 90. That's strange. I don't know why that happened. All right, so whenever I solve this, I subtract 15. 3x is equal to 75. And then I divide by 3, and I get x is equal to 25. Once again, the directions say find the value of x. That's what I found. So I'm done with that problem. Again, try 6 and 7 on your own. And if you have any questions, as always, come to class prepared with them.